What do you think, Brian?
Oh, good. Yeah, sure. How many do we have?
We're up to this.
Okay. All right, we might as well get going then.
Yeah.
Okay. Good afternoon. Thanks for joining us, everyone. I'm Brian Murphy. My colleague here, my Cybera colleague, is David Chan. And before we get into our introduction to Callysto, we thought we'd tell you a little about who we are, and we are Cybera. Cybera is Alberta's not-for-profit that oversees the management and development of the province's digital infrastructure. Most of you are from school boards and districts that are members of Cybera, and we've been involved with Alberta's K-12 schools and post-secondary institutions for several years now. And here are some of the things that we do for K-12. We manage the Research and Education Network in Alberta. It connects Alberta researchers and educators with each other and the world, high-speed service, and lots of it. Cybera also runs several shared services for educators. We do bulk buys of internet service, ensuring low rates and high speeds for everyone. And that means that all schools across the province have access to the same low-cost opportunities to bring the internet into their schools. Cybera runs its own rapid access cloud, that's what it's called, and it's a free cloud computing resource for Alberta-based academics and researchers, and a virtual firewall service. And Cybera maintains one firewall for all its users at the gateway to the network, and that saves people some time, and it's a state-of-the-art firewall. Now, funding. Cybera gets money from the provincial government and from other government sources to run programs and testing and development of new projects, and from the private industry, private side also. And that's why we're here today, is because of CANCO, which was Ottawa's initiative to improve computer awareness in kids and get computational thinking established in Canadian schools, K-12. And the name of that initiative was CANCODE, and people were asked to come up with learning platforms that would do just that, that would enhance computational thinking. And we put together a proposal with a partner, PIMS, which is the Pacific Institute for Mathematical Sciences, and we came up with Callysto. And Callysto is a cost-free learning program aimed at grades 5 to 12. And that cost-free involves free training for teachers and free support for teachers once they go through a training process that will be evolving in the next few months. The cost-free initiative is very important, we believe, for teachers. And it's available right now. Callysto is available right now for teachers who really feel comfortable with computers and research platforms. But we really want to have it online for all grade 5s to 12 teachers for the coming school year in September. And we'll be talking to you more about that, about getting it online, and people who want to get on board right now. Now about the name, Callysto. We were thinking really out of this earth off this planet when we came up with the name. And it also is a nod to the platform that we use, that is the basis of Callysto, which is Jupyter Notebooks. And Callysto is a moon of the planet Jupiter, and of course Jupiter is a planet. So we're sort of revolving around the science platform called Jupyter Notebooks. Jupyter Notebooks, it's a university-level research tool. It's used around the world, and it will work fine in Alberta schools because it's web browser access. Any modern web browser can put you right online and accessing Callysto and Jupyter. It's compatible with any desktop or laptop, including school-issued Chrome notebooks. It's hosted on Cybera's Alberta-based rapid access cloud, easy for use and security. And it connects to open data sites, which is very important for some of the learning modules that we envision. and it is able to categorize, analyze, and produce highly visual graphics, narratives for students to explain their research and assignments that cover all academic disciplines from the hard sciences to the humanities. And Jupyter Notebook was developed, the development was led by a researcher at Berkeley, and the two goals were to establish computational narrative using live code, narrative text. It supports basically the student's description of the report that they're doing on whatever subject it is, and it's called literate coding, and it leaves room for descriptions of what coding was used and why, which is all about the shareability of Jupyter and its ability to collaborate with it, because everything is explained step by step, and students have room to use their narrative skills in explaining their assignments. It's basically an all-in-one teaching and learning platform. It hosts the narrative text, and it's browser-based, so it's very easy access. It's safe. It's on our Rapid Access Cloud, and we think it's going to be a real boon to grade 5 to 12 students in terms of learning computational skills, thinking skills, and an introduction to coding and an understanding of data and other sophisticated computing platforms that are really not available to them right now. Learning with Callysto goes from grade 5 math to grade 12 social studies, and there are applications for Jupyter Notebooks in virtually every subject. And now that David is going to take you through some of the learning, the demonstration notebooks that we've put together that cover a wide area. And after that, we'll talk a little bit more and also have room for questions, your questions about Callysto and Jupyter.
Okay, thanks, Brian. So with some of that background in hand, yes, we wanted to walk you through some examples of how you could use Jupyter Notebooks in the classroom to hopefully highlight some of the versatility of Jupyter Notebooks and how they might be applied in the classroom. One thing of note, actually, Brian mentioned that it's browser-based. So this presentation is actually running using a Jupyter Notebook, and it's hosted on this cloud that Brian mentioned previously. And so we're doing this all through a web browser, so hopefully eating a little bit of our own dog food here, showing that this actually works. So let's get started. I wanted to start with two quick examples, how you can integrate open data into a science lab, and also quickly showcase how you can sort of augment a lesson about the American Revolution using Jupyter Notebooks. So I'm going to hop into the first notebook here that revolves around investigating conductivity using a Jupyter Notebook. I think one of the concepts that we wanted to demonstrate here is that you don't have to totally change what you're doing in the classroom today. So Jupyter can be used to augment what you're currently doing and hopefully add a new twist to it to maybe provide a bit of a new flavor and maybe strengthen your lesson in certain parts. So this lab that we're going through here talks about investigating conductivity in different solutions. It's probably a lab that we've all done at some point during our schooling. So what you can see here is very similar to what the students would see in a textbook. They can see here through the Jupyter Notebook. And so you can have fully marked up text here in the Jupyter Notebooks where everything is formatted properly. So they would read here about the question that they're dealing with of the day. How does conductivity of different solutions compare? What is their hypothesis? They could be asked to write their own hypothesis. So right in here in the Jupyter Notebook, they can write down their thoughts and their observations during the lab. So I think all solutions will conduct equally well, right? Whatever they come up with. You would have your materials and equipment outlined here as well, along with the procedure of the lab. And then inline as well, you can have a data table that is interactive that they can modify and enter their observations into. So they would, pour some distilled water into a beaker, measure the conductivity of it, and put the readings into this table. Now I cheated a little bit here because I pre-populated this table with some values. But basically, you can see that you can go in and write, my first reading was 125, my second reading was 250, not very consistent. And then in the notes field, you can write things like, I might have dropped some salt in the second beaker or something like that, right? So you have an interactive table that the students can use to write down their notes. Then they can use that data that they just recorded for additional purposes in the notebook. So they would have a button here that says click to save the data. So they save the data so they can work with it going forward. And just like any other lab, you would step through this as you would if you had a textbook in front of you, but now it's delivered here in this online platform. So you'd have questions about the lab that they can answer here in line again, fill in whatever answers they want to hear, answer A, B, C, whatever their interpretation is of the subject matter. But then I think where the different part comes in a little bit and where Jupyter can shine is how you can apply it and connect it to the real world. In this case, what we've done is we connected this Jupyter notebook to a water treatment plant in Edmonton. So this is a water treatment plant that's run by EPCOR, and it reports data from the Rossdale zone, basically of water it produces for that area in Edmonton. And what it does here is it reports on the various quality indicators of the water that is treated at that plant and as its output. So you have total hardness, pH, temperature, things like that. But what do you know? It also reports on conductivity of the water that is being produced. So it's sort of neat because now, maybe some of these students that are running this lab actually live in Edmonton, and this might actually have a real life connection in terms of the water that is being produced from the treatment plant in their neighborhood and the lab that they're conducting in the classroom. And so what's also maybe different from using a textbook is you can see here in the column headers that the data that's being reported from the EPCOR water treatment plant is for the last 7 days. So even though your textbook might be 15 years old, and you could also have data from a water treatment plant in your textbook, that data might be 15, 20 years old. And that would happen with Jupyter notebooks because it's a live cell and it's a live connection to that data feed. So if I pop this open in June and I run this again, then it will report back to me the data values for the last 7 days in June when I'm running this notebook. So it's very current, again, hopefully making it slightly more tangible or for some of the students. And then again here, this is sort of pre-populated because I filled in the table earlier, but as the student fills out the table, they can update this plot and visualize what do their readings look like that they just collected and how does it compare to the water that's being produced in Rossdale. So you can update this plot and you'll see here it regenerates it. Now we have the water, the reading in here as well for the distilled water. And you can compare this to in this blue dotted line, or sorry, this solid line with the blue dots, which are the conductivity readings coming out of Rossdale. And so you can imagine that maybe, certain things start to click in terms of, hey, look, the salt water has a really high conductivity, higher than the water coming out of the Rossdale treatment plant. What does that mean in terms of how much dissolved salts there are potentially in the Rossdale water treatment plant or in the water coming out of that plant? And so again, making that real life connection there. So that's sort of very, very basic how you can use a Jupyter notebook in a lab that many science classrooms are already running. Another example I wanted to give you deals with course material out of a history class in grade 5. And this example is sort of neat because it comes from one of our coworkers here who has a student in grade 5, and she spoke to her history teacher, her student's history teacher, and asked them what they're currently working on. And so one of the pieces that they're talking about is the American Revolution and some of the battles that took place in this. And so again, you're not totally switching focus in terms of what you're teaching, but you're sort of augmenting it and hopefully giving it a new twist, a new flavor in terms of how you can teach that content. And maybe it will resonate a little bit differently with some of the students, or maybe it would have resonated with 15 out of 20 of your students. But then using a Jupyter notebook, maybe you'll get three more students in the classroom that find this really fascinating. So what we've done here is imported some of the data about the battles during the American Revolution and where they took place on the East Coast. So you can see here the raw data here and where it comes from. It actually comes from Wikipedia, I believe. And of course, that's a contentious issue in terms of being a good data source or not, but we'll ignore that for now. And then what you can do is you can plot this all on a map and see where the battles took place. And so then you can animate this, and then the students can sort of see how over the years, where did the battles take place, how did this unfold, and which parties won. So on the right-hand side, you see the legend here. Was it a Patriot victory? Was it a British victory, or is it unknown? And then if the students want to rewind, they can play around with this timeline here. They can take a look at the individual years, and hopefully, again, this gives them a bit of a different flavor in terms of how they can work with the material, and maybe they can develop some a different type of understanding of what the data is saying. You can further analyze this data, for example, looking at how many battles took place each year, and you can see really that it sort of peaked in 1777 and 1780, where most of the battles took place, and you can color code this. So the dark blue means most of the battles, the highest number of battles that year, and then lighter blue means less battles. You can also simply plot this as a bar chart here, kind of seeing, okay, looks like in New York, most of the battles took place. You have 28 there, 26 in South Carolina, and then you can go down the line sort of and see where else these battles took place. And interestingly, actually, 3 battles also took place in Nova Scotia. So through these examples, hopefully, it provides a bit of an indication of what you can use Jupyter Notebooks for. So a new perspective on history. So using that history textbook, notebook, maybe you can engage a slightly broader section of the classroom. Someone who would have traditionally not been interested in history might really like to tinker with that timeline and see how the battles unfolded over time. It enables interdisciplinary learning. So taking content that's traditionally, history that you would maybe read about and maybe is not as interdisciplinary, you can bring some math into, some graphing, some plotting, and potentially some computer science as well. And it allows students to tinker and experiment. So they can look at that bar graph that we showed you. They can zoom in on various regions of it, but they could also modify that bar graph. So maybe they're interested in, okay, so now I have how many battles took place, but maybe I really want to see how many casualties were there in each battle, and they can modify that bar graph to update that and look at a different side of the data that previously they didn't get a chance to look at. And you might get students interested through interactivity. So rather than having material that's presented in a textbook or through some other static means, you can build in interactivity into these Jupyter Notebooks that might make it a little more tangible for the students to work with. Integrating open data into a science lab, so tying in that real life data might provide some new meaning to the experiment that they just did. The last example that I wanted to walk you through real quick is maybe a bit more of an advanced example, dealing with grade 12 social studies, source analysis. We try to teach our students to think critically. Fake news is a bigger topic than ever, everywhere you go. And so trying to be critical and having that digital literacy to understand where the data comes from and what it means. So in this case, what you could potentially do with your student is look at an article that was written up by the LA Times, where they talked about wage rises in California farms. I think there's a hypothesis going around that, immigrants come in and take good-paying jobs away from American citizens. And so the argument that the LA Times here makes is that Americans, while wages have been rising on these farms, Americans still don't want these jobs. And what's sort of neat here is that, they presented some data in this article, how the wages have been changing over the years. But they also provide in a Jupyter Notebook exactly how they analyzed this data and how they came to these conclusions. So this is where Jupyter really shines as well, because it allows you to do that literate programming where you can write down the thought process that went into your analysis and exactly juxtapose that with the steps you took, with all the pieces of code you ran to actually arrive at the numbers that you then put into your article. So you could share this with students. They could take a look at this and they can start to dig into this data and see, did the LA Times actually analyze this properly? What assumptions did they make when they looked at this data? What kind of data might they have potentially cut out? And start to, think critically about the data that you're looking at here. And what's kind of neat about this is, okay, this is a Jupyter Notebook, but look, this is all static. I can't really do anything with this. So what's kind of cool is that you can actually, through a link such as this, provide a link to your students that they click on, and then it populates that, it grabs all of that content that was provided by the LA Times and plops it right into that cloud that Brian was talking about. And now what each student has is their own version of exactly that material that the LA Times used to analyze their data. So now you can hop into this notebook. So now it's not static anymore. Now it's my version of it. Now I can do whatever I want with it. And I can rerun exactly all the analyses that they ran for the LA Times. And you can see here, I can mess around with this. I can break this if I want to. Let's see, I should be able to break it anyway. I can break, so this is live. So I can mess around with it. I can change it. I can update it. So the students can dig in here, again, testing some of the assumptions that were made. This is looking at crop data. What if I don't want to look at crop data? I want to look at all the wage data. And they can start to tinker with this and make this analysis their own. So really, I think, sort of unique in terms of what you can do with some of this source analysis. So some of the benefits that we think Jupyter provides there is, you can use Jupyter to show your work. The LA Times used it to show how did they analyze the data, so that if anyone questions it, they can go in, they can ask questions, and start poking holes into the theories of the LA Times. You can explain your thought process, that literate programming where you can intersperse the code with your reasoning for why you analyze the data in that way. You can put that all into a Jupyter notebook and present it that way. And it allows others to build on your results. In this case, we're taking data, we're taking a notebook from the LA Times, and I can take it and I can modify it. But it doesn't have to be that complex, right? It can be your student's conductivity experiment, and they wanted to share it with their partner, or they wanted to share it with another student in the class, and they can take it and they can reformat the plot. They can use the data that student A got and reformat it and reanalyze it in a different way. So it's a good way to build on results, sharing data, and again, tying in real-life data. And so I think throughout all of these notebooks, hopefully, you saw the sort of the core concepts of introducing ideas around computational thinking and allowing students to explore further if they choose. So everything is fully compacted into these notebooks, so they can, we summarize a lot of things here, but they can expand on it and they can explore further as much as they want. So if something really resonates with the student, they don't have to stop there with the material you provided, but they can take it and build on it using these Jupyter notebooks. And so,
oh yeah, and we'll have we're going to leave a little time for questions at the end on Callysto and Jupyter. But we just wanted to say that Callysto is really just getting started, and we're looking to sort of cooperate and collaborate with teachers to really get this thing off the ground and to create your ideal learning modules. So if we could get input from teachers on the sort of courses that they want to see, we'll work with you to develop those ideal teaching modules. And we can do that through the no-cost training and the no-cost workshops that we'll be getting going towards the end of the school year. And there'll be, of course, no-cost ongoing support throughout the school year. We're trying to make it as easy as possible for teachers to get involved and move forward. And the more adventurous of you can get on to Callysto now, but our goal is to see every interested grades 5 to 12 teachers in Alberta using Callysto in class this fall, in the fall of 2018. And we have a pretty lofty goal that by the spring of 2019, we want to have 750 teachers of grade 5 to 12 students. That would account for some 25,000 students across the province using Jupyter notebooks in the classroom. So that is our goal. And we would like you to consider what content or learning modules could be delivered using the platform, and let us know, and we can work with you to make that happen. Collaborate with our support teams and to adapt and create content, curriculum-based content with all the learning goals included, and the workshops are a place for people to get up to speed on it and to discuss and help develop these perfect learning modules in your class.
Yeah, Brian, if you don't mind, I'll just jump in. So really, yeah, we're looking to work with teachers actively. If you're interested in using this in the classroom in the fall, and you have an idea of, I want to use physics module, chapter 8.3 would make a really great module that I could adapt to a Jupyter notebook. Please come forward, tell us about it. We'd love to work with you to help develop some of that content. So it's not build it and they will come where you're off on your own, but we'll help you and we'll help develop some of that content with you So let us know, and we'd like to start working with you as soon as you're ready to help build out some of that content. Brian mentioned the workshop, so sorry, I'm not sure if it's not showing up. Yeah, so I think now you can see it. So we're scheduling the first workshop in the second week of May in Lethbridge, so to do a bit of an introductory workshop on how to use Jupyter, and again, to get interested teachers out there, out and start working with them to help develop some of those modules.
Yeah, so that's our introductory lesson on Callysto Jupyter, and we really hope you participate, and starting as soon as you possibly can. And does anyone have any questions for us on what you've seen today?
So I think there's a chat module that you can use if you have any questions.
There's a question.
There's one question? Okay. Let's see. Yeah. So how do we offer to train teachers that might think the coding component is too challenging? So absolutely, that's definitely a bit of an obstacle. So one piece of support that we're hoping to provide is to actively work with teachers. So let's say you have a module that you want to develop, we can actually work with you to either help you, or it's not. I don't think it's out of the realm of possibilities that we actually develop some of the modules for you. But the question about learning how to program is definitely an important one. And I think, so we're looking at partnering with other organizations that specialize in exactly that. So how do you get teachers that are not comfortable with programming up and running? How do you provide an introduction to programming to them? And so that's not our area of expertise. And so we're looking to partner with other organizations that specialize in that, and see if we can get teachers that want to develop their skills in that area up and running, so that they might feel more comfortable using Jupyter. That being said, to run any of these notebooks, if they're pre-built for you, you don't actually need to know any programming. So it's very straightforward in terms of executing the cells once it's pre-built for you. So it's not necessary that you know a whole bunch of coding to use some of these notebooks. To develop them, yes, but to use them, that's a different question.
And we've talked with teachers who are technology leaders in some schools, and they've run classes for their fellow teachers, Introduction to Code, and within a few hours of classes, these teachers are getting a full understanding and sort of up and running with basic code. And once you're up and running, it's like riding a bicycle. You just keep going faster.
And there's one more question here. So how are students learning about code through Jupyter? And I think just one distinction I think we want to make is just between learning how to code and learning about computational thinking. So I think there's a bit of a distinction to make in terms of starting to think about solving problems in a computational way, starting to learn about thinking algorithmically and things like that. So just making that distinction. And in terms of how to code, so what we didn't show you is that you can unroll all of those notebooks to reveal the code that was used to create them. So you can definitely do that, which would allow students that are interested to provide them a window into the code that is used to build those notebooks up. So for students that are really keen, it might give them an entrance there. Also, you could develop notebooks simply for introductory, teaching how to code notebooks, essentially. So we didn't touch on those here, but that's also a possibility. And actually, David Hay, who works in Alberta here, has been using Jupyter Notebooks already in grade 6 for math and teaching about functions in using those notebooks, which I think is an excellent example as well that we didn't touch on here. But that's where you start seeing some of the coding principles tied in with concepts of mathematics. And so there you're teaching math really, but at the same time, somewhat through osmosis, I think you're starting to learn about certain principles around coding as well, and that hopefully will help the students, get exposed to coding and learning about coding. And I think actually it's been a pretty cool success story in terms of what David Hay has been able to do in grade 6, because he's been able, he mentioned that, he's been sort of popping this up in various courses of his, and as students walk into his classroom and he has a Jupyter Notebook on his overhead projector or whatever he's using, students walk in and say, oh, cool, we're doing Python today. And so it's sort of, you don't have to sit them down and tell them, this is how you write a while function, this is how you write an if statement and things like that. But it's almost maybe a bit through osmosis. Maybe this is naive thinking on my part, I don't know. But hopefully, I think in an ideal world, it would work a little bit like that.
And David got his young students through the introductory programs for coding, where you make a turtle, you program a turtle to walk in a circle or walk in a square. He got them through that within a couple of days, and then they were off and running with the coding required for their math training.
So it is 4:03, so I do want to be mindful of the time. Thank you all for joining the webinar today. Thank you for your questions. If you have more questions, please email us at callysto@cybera.ca. We hope this was a little bit helpful. We'll also be following up in the next couple of days with a form to collect some feedback. And again, if you want to work with this, we want to hear from you, and we want to start developing content with you. So please take a look at the form and indicate to us if you have that desire to start building up some of that content. And again, if you have additional questions, email us, or you can submit them through the form as well. So if there's nothing else, Brian?
And everyone has my email for any questions or connections to other elements of Callysto. Just fire away.
Then thank you very much, everyone, for attending, and hopefully we'll be in touch soon with everyone.
Thank you.